Good afternoon, Mr. Seacher. How you doing?
Good afternoon, Miss Masters.
All right.
How are you doing?
I'm doing good. I'm just gonna take a few minutes. Thank you for allowing me to come in and record you and provide feedback. So I would like to also, I want to always start off with, we're going to talk about celebrations, and then we're going to talk about as far as how you think your observation went. Okay, I'm going to let you view yourself in action, and then identify what went well, but also identify if there's any gaps based on the feedback that I'll provide, and then we're going to talk about it, discuss it, and then you're going to go and remodel. Okay, with those upgrades, and then we'll come together with the next action step and then a follow-up date to return to view those upgrades. All right, so let's start off with celebrations. So during your observation, I did notice when I was coming in, students are being prepared to start their stoichiometric calculations. I know you've been working on that all week, and today was the week to have even more practice so you can address any misconceptions or even close any gaps before they take their, DOL. Or it can also, I believe, it could have been a reteach, but the fact that you identified they need more practice is a good way to actually progress monitor and not wait until the end to address those misconceptions. So with that being said, you knew the importance of a quick reteach. And when I say when you had your reteach, I like how you did start to annotate your thought process. You focused in and you identified those key terms that the students need to know. You identified units, and you also use the formula that is actually needed to use. So it's very important that students be able to see the formula and how to substitute those numbers within that formula. So thank you for doing that.
Thank you.
All right, so at this time, I like to kind of talk about how can you incorporate the new paper partner strategies, which is the annotation tool that the students need to be able to begin to use to show their thought process. So we know that the ACP is coming up, and we know the ACP is online, okay? So what do you think are some key tools to look for, or key things to look for when students are showing their work? When they're showing their work and their thought process, what are the steps needed to solve, let's say, the problem that you was working on today? What were some steps that's needed for them to be successful?
They need to know what is the chemical equation written on the board, and the number of moles, that is the coefficient written in front of the compound or an element. So that's the main thing. Then they should read the question well and find out what is actually needed in the question, what they have to find out, and then what is given. They will have to identify them. Then they can solve the equation. So these things I keep reminding them. What is the question? Read the question. What is being asked? So which compound's value do you need to find out? So what is given? And the units, whether it is a mass, by seeing the grams, they should know that they are questioning about the mass. If it is in L liters, then they should say it's a volume. Then they write the equation accordingly. So
Okay.
this is the main thing that they need to find out.
Okay, so I'm glad to hear that you're able to articulate what is it they need to be successful in order to solve those calculations. Okay, so one thing that we stress that's important is when we're in chemistry, chemistry is math. So we know that our paper partner strategy, which we call AKA screen to scratch. So ELAR use screen to scratch. We call it paper partner strategy. It's the same thing. However, it's very important that students have a clear direction of where they need to go step by step of how to solve these problems, okay? So that's when the paper partner strategies come into effect. So with chemistry, we're going to lean towards the math component of the paper partner strategies, which is actually was given, which you stressed that, the question, students have to identify what is the question being asked and how to solve it, and then elimination if necessary. So with your calculations, there is no necessarily eliminations, it's more of open-ended responses, okay, or short constructive responses. So what I would like to do is just go over how to actually annotate this problem using the paper partner strategies. And what I would like for you to do is just kind of listen to what I say, and then I'm going to kind of try to go through a quick model of how that actually looked like with your problem that you was working on today. Then I would like for you to watch your video and then identify if there's any gaps. Okay. All right, Mrs. Cedra, so when we're dealing with math and science, we're gonna actually focus on the paper strategies that's dealing with those steps: giving, question, solve, and eliminate. What does that look like in stoichiometric problems? Well, in this particular problem, the given is actual things that are given. We're given the chemical equation. We're able to identify the number of moles. Okay, we're given typical yield, which is in percentage. And we also given the number of grams of zinc sulfate. Then the question is actually asking, what is the mass of sulfur dioxide when given 4897 grams of zinc sulfate? Okay, so that is actually what's given. Okay, so when you talk about the steps, we want to actually have clear steps of what that actually look like. And then the steps of how to solve it. Step 1, step 2, step 3. So therefore, when kids actually are released to do the work, you can actually say, okay, what's step 1, what's step 2, what's step 3? They're gonna know that because they're gonna see you modeling step 1, step 2, step 3. So in this case, step 1 can be identify the number of moles in the equation, it could be step 1, for each of the chemical formulas in the equation. Step 2, calculate the typical yield. So we have to identify the typical yield is in the problem, and then we're going to calculate it. But before that, we're going to convert percentage to decimal. Okay, that's for these type of problems. And then step 4, so on, so on, so on. So what I would like to do is kind of just model briefly of how that would actually look like in this problem. Then I'm gonna let you take over. How does that sound?
Yeah, that's how it.
All right. So the first thing I must do, I must actually read the problem. Okay? So if the typical yield is 86.78%, what mass of sulfur dioxide should be expected if 4897 grams of zinc sulfite is used? So how does it actually look with paper partner strategies when we're dealing with the math component? Well, first I need to actually identify what's given in the problem. So what's given in the problem is going to be our equation. So I'm going to put given. So our equation, I have 2 moles of zinc sulfite plus 3 moles of oxygen yields 2 moles of zinc oxide plus 2 moles of sulfite dioxide. Hopefully I'm saying them terms right. So I'm given the chemical equation. I'm also given typical yield. So I'm going to write, I'm given typical yield. Which is 86.78%. And I know oftentimes in math we use Q's, which we circle in the numbers. Here I clearly see 86.78 is the number that's of importance. But I'm also going to go ahead and circle 4897 grams of zinc sulfite. But I'm also going to put what else is given is 4897 grams of zinc sulfide. Okay, let me see if there's anything else that I need. I believe that's it. So the next step, so that's step 1 was given. Step 2 is going to be the question. Okay? So what is it that the question is asking me? So what is the mass sulfur dioxide if expected if 4897 grams of zinc is being used? So I'm going to come back here. I'm just going to put is used because that's important. Okay? So that's my question, what is needed. I'm going to put a little question mark. I'm just going to abbreviate it. Step 3 is going to be solve. And that very well may take a few steps. So I do know I do have to convert, use the typical yield formula. Okay? So, Mrs. Teacher, I would just like for you to help me out. So I'm actually writing the step. I need to identify the moles. So I'm going to identify okay. So the next thing I'm going to do, I'm going to calculate typical.
Not typical, theoretical. Typical is given.
In percent.
Okay.
Okay.
Typical.
So we got to calculate typical yield and convert it. So we'll say convert
Conversion.
to a decimal. I do want to backtrack. What is also given that we know because we have it with us? We have our formula chart. Mrs. Teacher, can you help me out?
No, we don't have, that is percent for yield. Percent yield is equal to actual yield by theoretical yield.
By
Theoretical yield.
theoretical. Okay.
Yeah, theoretical yield times 100%.
Okay, so I do know that formula. So I'm going to come down here and then I'm going to make sure we have typical yield, percent yield.
No, percent yield.
Okay. Divided by theoretical
Yeah.
times 100. And so the typical yield is given, which is 86.78 over
100.
100, which will give us our,
0.8678.
okay, so
0.8678.
we got 0. So we move our decimal place 2 to
Yeah.
the left. Okay. All right. For time's sake, I'm going to stop right there. All right, Mr. Teacher. So at this time, I would like for you to observe your video of your observation and then just kind of see how it went and then identify those gaps from what you did this morning and from what feedback that you saw me do, and then we're going to talk about the next steps. All right, Mrs. Teacher. So based on you viewing yourself, going over your actual calculations, what are some gaps that you observed that you had that you know you need to upgrade or you're going to add next time you teach this?
I said orally what is actually given and what is the question. I made them to elicit, I elicited the questions from the students, but next time I'm going to write whatever they tell me, I'm going to put it on the board so that they will understand what is given, what is the question asked, and how to solve the sum.
Okay. All right, so we're going to take some time. I want you to just take a minute to just kind of go through the process of your problem. You're going to kind of go back up there and model with those upgrades, you're gonna make sure you stamp what's given, what the question's asking, how to solve it, and then, of course, we don't necessarily have eliminations, but you can kind of talk it through as far as maybe addressing misconceptions. So this is what you're gonna do, so just take a minute how you're actually going to show that. So remember, you wanna model this annotation, screen and scratch, so your kids can know exactly step by step what they need to do. All right? Are you ready to go, or you need more time?
No, I can go.
All right.
So, the given. Now, what is given here? The equation is given. So, equation is given. First chemical equation. First thing you will have to see the equation, and then moles. What you can find in the equation? Moles. So, from the equation you will have to note down the moles. Then, come on, now read the question. So what is given here? The typical yield is given. So the typical yield is given, the value of the typical yield. And then now here there is another one, mass of zinc sulfide is given, that is 4,897 grams. Okay, this is given. Now we will go to the question. So what is being asked here? You need to find out the mass of sulfur dioxide, and then we will have to find out the theoretical yield. So these things should be answered. Then we will go to the solution. Solve. Solve now. So we will have to now solve the equation. Find out the answer. So first, what is given? What is asked? Here we need to write at the top. Now zinc sulfate, here it is 4,897 grams, and then we will have to find out the grams weight mass of sulfur dioxide. As we cannot go directly, we cannot find out directly, we will have to convert that to the mole of zinc sulfide. Then from mole of zinc sulfide to, we will have to come here, find out the answer for mole of sulfur dioxide. From sulfur dioxide to mass of sulfur dioxide. Now first thing we will have to write the question. What's the given? What's the question asked? Grams of sulfur dioxide. Now what is given here now? We are going to take from the previous page given. So that is 4,897 grams of zinc sulfide is given. Now we are going to find out now.
All right, and time's up. Due to the bell, we're going to wrap this up. Okay, Mrs. Teacher, I'm going to conclude our feedback session. So just give me a few more minutes. I'm going to turn the camera around. Just have a seat.
Okay. This is submitted by the district or Mr. Joseph?
At this time, we're going to make sure that, thank you for actually monitoring with those upgrades. I just want to make sure you are clear as far as your next action step. So the action step was to name the action step, was to model the thinking and not just the procedure. So we want to model the entire thinking of how you solve those calculations using the paper partner strategy steps. So what's given, okay, the question, the steps needed to solve it, and then if there's any multiple choice, you eliminate and justify. So thank you for actually doing that. So I want to make sure that are you clear about expectations moving forward with calculations?
Yes.
All right, so we already have, planned it out, you modeled it, so now it comes to next week. So I'm going to be back Monday, and I'm going to observe the changes that, you're going to start to implement.
Sure.
Do you have
Yeah.
any questions?
No, thank you.
Uh-huh.
I will follow the.
All right, thank you.